Welcome to The Explainer. Today, we're rolling up our sleeves and breaking down the precise, nuts and bolts mechanics of reporting waste management metrics in the construction materials sector. If you deal with sustainability reporting, well, you already know the devil is absolutely in the details. And that is exactly what we're going to master right now.
Okay, let's actually think about the scale of this challenge for a second. The construction materials industry, we're talking cement, aggregates, glass, roofing, it generates a literally staggering amount of byproducts. We aren't talking about tossing out a few bins of scrap in the back alley. We are talking about industrial-scale waste pouring out of massive production processes and pollution control systems. Getting your reporting wrong on this, it carries huge regulatory risks, potential litigation, and totally unexpected operating costs. So how in the world do we accurately measure all of that?
To figure that out, we're going to use a categorization funnel today. We'll start with wastes in construction materials, narrow down to the total waste generated, filter through calculating hazardous waste, and finally, calculate the recycled waste.
Let's kick things off with Section 1, Waste in Construction Materials.
Now this perfectly illustrates the exact SASB standard we're unpacking today. We're zeroing in on the waste management topic, specifically metric code EMCM150A.1. This metric demands strict quantitative transparency across three very specific pillars. You need the total amount of waste generated, the exact percentage of that waste that is hazardous, and the percentage that is recycled. The ultimate goal here is to help entities mitigate those crazy high compliance costs tied to rapidly changing environmental laws.
Just to give you a real-world idea of what we're actually measuring, the reigning undisputed champion of waste in this industry is cement kiln dust, or CKD for short. Basically, this is a super fine-grained, highly alkaline solid waste that gets scrubbed right out of cement kiln exhaust gas by air pollution control devices. It's essentially the steep price the industry pays for keeping the air clean. And because it's a byproduct of pollution control, it is a massive driver for these strict reporting requirements. Mishandle it, and you're looking at a huge regulatory nightmare.
Moving right along to Section 2, Total Waste Generated.
So, here is the absolutely crucial point. Before you calculate any fancy percentages or ratios, an entity has to disclose the sheer, raw physical weight of its total waste generated. And it has to be reported in metric tons, no exceptions. This is the ultimate denominator for literally everything else we're going to calculate today. If this baseline number is off, your entire disclosure is completely busted.
But hold on, what exactly counts as waste? To get this right, we have to follow the standard's incredibly strict definition. Waste is anything, and I mean anything, for which the entity has no further use and which is either discarded or released to the environment. That specific phrase, no further use, is your operative standard right there.
Now, what's really fascinating here is the hard boundary the standard sets. When you're calculating those metric tons, you have to include solid and liquid byproducts. We're talking slags, dusts like that CKD we just mentioned, sludges, and used oil. But gaseous waste is entirely excluded from this specific metric. Gaseous emissions have their own separate air quality metrics, so we draw a very hard line right here to prevent any double counting.
Okay, down into the funnel we go. Section 3, Calculating Hazardous Waste.
Let's see how this builds into the actual math. Once you have your total waste in metric tons, you've got to figure out the hazardous percentage. Step 1, weigh the hazardous waste. But how do you legally define hazardous? Well, the SASB standard says you have to use your local jurisdictional framework. Now, if your operations happen to be in a place that lacks those definitions, you default straight to the UN Basel Convention. Step 2 is just simple division. You take that hazardous weight and divide it by your total baseline weight from Step 1.
Generally speaking, the waste that makes it into this hazardous numerator displays one or more of four pretty severe characteristics: ignitability, corrosivity, reactivity, or toxicity. For sure, entities that can re-engineer their internal processes to reduce these specific, highly volatile streams are the ones that significantly bring down their regulatory and litigation risks over time.
And finally, the bottom of the funnel, Section 4, Calculating Recycled Waste. The math here mirrors the hazardous calculation we just did, but honestly, the numerator is a much more complex sum. To get your true recycled percentage, you have to add up the weight of materials reused, recycled, or remanufactured by the entity itself, plus the weight of any materials transferred to a third party specifically for further recycling or refurbishment. Got all that? Then you divide that grand total by your baseline metric tons.
Let's quickly unpack exactly what counts as recycled or remanufactured under these rigorous definitions. Reused materials are recovered and used for the exact same purpose they were originally conceived for. Primary recycled materials are actively reprocessed into a totally new final product or component. The definition also includes co-products, which hold an equal value to the primary materials, and byproducts, which have a lesser value. All of these get added together to build your recycled numerator.
But hey, to avoid some very serious compliance pitfalls, you have to keep this next distinction in mind. It is absolutely vital to remember that any fraction of material that ends up discarded in a landfill does not count towards your recycled percentage, period. Only the specific portions that are directly incorporated into new products, co-products, or byproducts can legally be claimed as recycled.
Now, the standard also forces us to look really closely at something called energy recovery. This is defined as using combustible waste to generate energy through direct incineration, specifically where you recover the heat. It's actually a super common practice in construction, manufacturing, especially inside cement kilns. But this brings us to a massive, critical caveat in the reporting guidelines.
And this is a boundary you simply cannot cross. The standard explicitly states, in no uncertain terms, that materials incinerated for energy recovery shall not be considered within the scope of recycled materials. Burning combustible waste for heat, even if it saves you a ton of fossil fuels, does not count as recycling. However, there is a bit of a silver lining here. You are allowed to separately disclose the percentage of hazardous waste that was incinerated. That way, investors still get a fuller picture of your strategy without you improperly inflating your official recycling numbers.
And that brings us to the bottom of our funnel today. By mastering these quantitative metrics, accurately tracking those total metric tons, safely classifying hazardous characteristics, and rigorously defending your recycled percentages, entities don't just achieve compliance, they uncover highly actionable data. Finding clever ways to reduce these waste streams can dramatically lower a firm's entire cost structure. So ask yourself, are you just doing the basic math to report your waste, or are you actually using these metrics to reveal your next great operational efficiency?